Hey guys, let's talk about atoms. There are a lot of facts up on this small whiteboard here, and I'm not really asking you to memorize these facts, but I would like you to listen carefully and take in as much as you can and be ready for that quiz on Friday because some of the information here will be on that quiz, okay? This is sort of a story, all of this. We can put it sort of in story form, at least part of it. So I'm hoping you sort of listen to this in a way as a story, okay? Like maybe you're sitting in a language arts class and you're listening to this story. So let's go ahead and get started on it, okay? What are atoms? Atoms are really mysterious things for different reasons. Well, one of the biggest reasons they're so mysterious is because they're so tiny. They are so small. Well, chemists say that atoms are the fundamental building blocks of chemistry. The fundamental building blocks of chemistry. Now, usually when you're talking about something that's fundamental, it's sort of like saying it's the basics of something, or it's the foundation, or where it's something begins. So chemistry really does sort of begin with atoms. Nothing that's done in chemistry has anything to do with anything really but atoms. And the reason for that is because atoms make up all matter. And what is matter? Again, matter is stuff, okay? Matter, if something takes up mass, space, has weight to it, it is considered to be matter. So you can think of matter as something that has mass and takes up space, okay? So matter, of course, can be things that we don't see as well, right? I'm looking at a chair right now, that's matter. I'm looking at a fan, that's made up of matter. I'm looking at this camera, it's made up of matter. There's a TV screen made up of matter. There's a rug below me that's made up of matter. All of this stuff is made up of matter, but matter is also matter is something that makes up gases as well, like oxygen, hydrogen, helium. Gases are things you can't see, but we know that they're there, right? And they are there because they're made up of stuff. They're made up of mass. They're made up of matter. And so the gases that we know are all around us are made up of atoms. So, what about atoms? Where are they listed? Where can I find a list of all of the different types of atoms that exist? Well, you've seen a list of all the types of atoms that we know of many times. And you've seen it on what we refer to as the table of, name it, elements. Yeah, the table of elements. Today's table of elements has 118 what we call elements. Now let's look at this. There are 118 kinds of atoms. And when you look at that table of elements and you see all those squares and all the letters and the numbers around the letters that make up the table of elements, each of those boxes or each of those squares is a separate element. And the element is a kind of atom. A lot of times that's confusing when we talk about table of elements or we're talking about elements alone and then we refer to atoms. People think, well, what's the difference between an atom and an element? Well, an element is just a separate type of atom, okay? So let's talk about a little bit of history here. Let's go back, way back in time to 400 BC, 400 BC. Remember, BC, standard BC stands for before Christ. So many of us believe that Christ existed 2,000 years ago. So if we go back 2,000 years, okay, that's 2,000 years ago. And then another 400 years before that, we're talking about over 2,400 years ago. So it's a long time ago, 400 BC. And the place that we're discussing here is Greece, okay? Greece. A lot of our very first ancient philosophers came from Greece. And philosophy really evolved and changed and over time became science, and religion and philosophy and science, and these types of practices were really considered a lot of them were considered really in a big way the same thing. Okay, so if you were way back at BC and 400 BC and you talk with a philosopher, you're really talking with a person who is very bright, right? They not only talk about philosophy, but under that umbrella of philosophy is also conversations and discussions about religion and science and other things. So, going back to 400 BC in Greece, we come to Democritus. Democritus is really considered to be the father of the atom. Now, why do we say that? Well, during Democritus's time, he had philosopher friends, and what we would think of now today as scientist friends as well, who had a very important question that eventually got answered, and the question was this. Let me grab a piece of paper here. Hold on. There's a good one down here. Grab a piece of paper, a Post-it. If I take this Post-it and tear it in half, okay, now we've got half the Post-it. Let's do it again. Let's tear it in half again. Shrunk down quite a bit. Let's tear it up again now in half. Okay? We tore it 3 times. Only 3 times and it got this small. Let's tear it again. There's 4 tears. Now it's this small. 5 tears. Only after 5 tears. 6 tears. Can you still see it? You think I can tear that again? Let's try it. There's 7 tears. That's what we've got after 7 tears. I think I can do it again. Yep, 8 tears. After 8 tears, that's what we're left with, and I don't think I can tear that again. Since I can't tear it again, does that mean that that's the smallest part of that original piece of paper that we started with? Is this what makes up that paper? Is this the smallest particle that when put together over and over and over and over again gives us paper? Well, the answer is no. Now, I could probably, if I really tried, I could tear that again, but that would be it. And even then, though, it's not the smallest particle. That was a kind of question that philosophers were asking in 400 BC. And Democritus was super interested in this. Now, you may be thinking like, so stupid, it's so simple. The idea is so simple. But really, the idea is not so simple, at least not the idea that he had. His hypothesis was this. There must come a point where you cannot break something down into a smaller part. In other words, you have such a tiny part there that not only is it too small to tear again or to break up again, you cannot break it up again because it is the origin of that material, of that matter. Therefore, it cannot be broken up again. In other words, billions and billions or trillions of these particles stuck together make that thing. And when you think of it that way, it really becomes more of a scientific concept, doesn't it? Well, what Democritus was really wanting to know was, what is an atom? And he came up with the word atom. And the Greek way of saying atom was atomos. Atomos. Okay? Now, what is atom? What do you think atomos means other than atom? So really the question I'm asking you is, what does atomos mean, or what does atom mean? Well, the answer is found in that little illustration I just gave you with the paper. What do you think atomos means? Atomos means smallest part. Smallest part. Atomos, Greek, and that's where we get the word atom. And we get it from Democritus. All right. Now we're going to move ahead. We're going to move ahead a little bit to the Arabic world. Actually, we're moving back. My apologies. 700 BC. So years even further back BC to the Arabic world. Okay. And in the Arabic world, what they were doing during that time was they were experimenting with stuff, and it was mostly liquid things. They were doing filtration and boiling and some other experimental manipulation with liquids. And what they determined when they were doing that is that you could divide things down into separate parts. In other words, if I boil something, think of it this way. If I boil water, what do I get? I get steam, right? Now those steam particles are still water, but those particles, if broken up, become something different than their origin or what we originally saw them as. And this is really what the Arabic world was most famous for, was manipulating matter to break it down into smaller parts. Okay? So, we're getting closer now in our discussion with Democritus and those philosophers in the Arabic world. We're getting closer to dividing things into pure substances. You know, that's going back to that original idea of the smallest particle that makes up something, right? The smallest particle that makes up something cannot be broken any further because it is the smallest particle that makes up that thing. In other words, it's pure. It's a pure part. Pure substance. Now, pure substance means that you take the pure part or the particle and you put a bunch of those same pure parts together and you have a substance. Maybe you're thinking water right now, right? The parts of water all together give you water. That's not really what I'm talking about. We'll get to that. Let's move on way ahead. Okay, we're gonna move like almost 2,000 years ahead to 1700 AD. So if this is, let's say that this is 0 on our timeline, okay, and this is before 0, going back before 0, and this is after, and here we are in 2020. Okay, we're going to actually go way over here to 1700. So we moved from way back here, 4, 5, 6, 700 BC before Christ, to 0, and then way up here to 1700. Which 1700s to us seems like a long time ago, but when you look at the timeline, right, it's not really that long ago. We're going to go to 1700, and we're going to look at these names, Lavoisier and Polska. Lavoisier was a guy, Polska was a woman, and they were chemists that worked together. What did they give us? They gave us chemical reactions. Up until this time, there were manipulations with liquids, and we talked about that in the Arabic world, filtration and water. They could boil the water, but they weren't doing any kind of any chemical reactions. They weren't causing chemicals to react by putting them together, at least not that they knew of. There were reactions going on all around them. They just didn't realize what they were. So Lavoisier and Polska gave us chemical reactions. And what happened as a result of those chemical reactions? Well, what happened was they began to show this concept of dividing things into pure substances. For example, H2O, we talked about this, becomes steam, and what they did, they showed that steam, if we break it down even further, those particles of steam down even further, what do we get? We get hydrogen and oxygen, and those are found where? On the table of elements. They are pure building blocks, right? So it was in the 1700s that we began to come up with this concept of elements, okay? Pure substance that are divided out. All right, so that leads us now to this 118 kinds of atoms that we list on the table of elements. This PTOE is periodic table of elements. Periodic has to do with the way they're listed. They're listed periodically based upon their weights and other things. That's not important right now for you. But periodic table of elements. What's on the periodic table of elements? A lot, okay? There's a lot of information on the periodic table of elements. And you will learn more about that if you take a chemistry class in high school. You're going to learn a little bit more about it on the second video that you're going to watch. But the periodic table of elements basically has gases and solids and liquids. Okay, and we can subdivide that down into a lot of other subcategories. But right now, for now, gases, solids, and liquids is what the table of elements has. Now, as we move along in time and we learn about more scientists and modern scientists, what we're finding is that reactions under certain conditions create something. In other words, when you take those pure elements and you put them together, and maybe you zap them with heat, okay, or in one way or another you cause them to what we call react or act again, there's a reaction, right? And that reaction gives us something, okay? It produces something different. Let's call this element A and let's call this element B. If I have A react with B, I get what? I don't get A, I don't get B, and I don't get AB. I get C. I get something altogether different. Really crazy. I mean, this is where the weirdness of chemistry comes in. The magic of chemistry. And we call those things, when we put A and B together, we get something altogether different. We call those compounds. That's an important concept. Compounds. The result of the reaction of two or more elements after they have reacted. You get compounds. What are some examples of these? Well, on the video that you're going to watch, they give you 3 or 4 different examples, but the one that I think is the most commonly known is if I take O2, which is oxygen, and H1, which is hydrogen, and I put them together and form a compound. What is that compound? You've probably guessed. That's right. It's dihydrogen monoxide. What? I thought it was water. That is water. So dihydrogen monoxide is water, right? It's that pure, wonderful stuff that we need to live. And water is a compound. And the reason we say it's a compound is because it's, do you find water on the table of elements? If you look at all those boxes, you're going to see H2O. You're going to see water? No. You're going to see H and you're going to see O, but you're not going to see H2O. That's a compound. That's the reaction process gives us H2O. Okay, so we're moving now into compounds. Well, as we move along on the timeline and get closer into the 18 and 1900s, what we're beginning to learn now is that if we have a chemical reaction, that's called a compound. Is it possible to reverse that? And the answer is now yes. We know that yes, we can. So we can reverse this process of bringing elements together and giving us compounds. And the person that came up first with this idea and showed us this fact was John Dalton. John Dalton is extremely important in the world of chemistry. Some people refer to him as the father of modern chemistry. And the reason they do is because he came up with 5 facts that we now know are absolutely true. And he also came up with the very first table of elements. Now, some argument whether or not it was John Dalton, but for the most part, scientists believe that he came up with technically the very first table of elements. And if you look at his drawings, okay, and of course there were not 118 of the elements at that time, but if you look at his drawings of the elements that were known at that time, it's amazing how closely his little pictures, his little illustrations were to what an atom really looks like. Yeah, we can actually see, we have seen an atom now. It's pretty amazing and it's very recent. Okay, so John Dalton, often thought of as the father of modern chemistry, lived in the 1800s, so now we're moving really close here to our modern time. And he gave us what's called atomic theory. It's a 5-part theory that gives us 5 basic statements. Now, when you're in high school, again, if you take chemistry, you're probably going to have to learn those 5 facts. All 5 facts have to do with things like an atom is the same size in its purity based upon where it is on the table of elements. Another one is when you combine elements, you get compounds, and those compounds are always made up of the same types of elements. Things like that. They're just basic chemistry concepts that John Dalton gave us. Now, were they basic in the 1800s? No, they were absolutely brand new concepts that the world knew nothing about. And so at that time, they were just brilliance, right? Just brilliance. John Dalton, that's a very important name to remember. All right. So wrote about and gave us a lot of information about, what is an atom? How does it react? When it reacts, what does it look like? Can you pull the atoms apart? If so, will you find that the atoms have changed size or not? John Dalton was involved in all of that. Now let's really push forward on our timeline, way forward to the 1970s. Really important decade, because in the 1970s, electron microscopy began to emerge. Emerge means to come forward. Now, electron microscopy as a concept was there, but electron microscopy in its purest sense did not exist yet. First of all, let's talk about what is electron microscopy. Well, electrons are parts of atoms. They're the negative little particles around the nucleus of an atom that float around. And we have an idea now because, imagine if an atom is really, really, really tiny, and it is, and you can't see it with a regular microscope, imagine how small the part of an atom is, like the electron or the proton or the neutron. So the electrons of an atom are the negative parts around the nucleus of an atom that float around. And microscopy, as you might guess, has to do with microscope, right? Microscopy, microscopy, the study of seeing things that are very small by using a microscope. So electron microscopy really in the end it means using very powerful technologically advanced microscopes to see the parts of an atom. This was in the 1970s. Now, in the 1970s, we actually were not able to see an atom. It wasn't until later, and actually like decades later, that we actually for the first time saw the surface of an atom. So what do we mean by in the 1970s we came up with electron microscopy and we didn't see an atom? What happened? Well, scientists like to say that we began to feel, in quotes, right? Because we're not actually feeling the atom and recognizing it through touch. But we began to feel the atom based upon the movement of the parts in the microscopes, the very powerful microscopes that we're using. They were able to take beams of light, which, by the way, the beams of light, which are so tiny and yet are way wider and bigger than an atom. And that's the reason we couldn't see an atom up to this point. But they began to learn that if I take beams of light and center them on a piece of equipment that's at an arrow shape, that will shrink the beams of light to even smaller beams. And if we can shrink those smaller beams to small enough, then we can shine them on that little teeny tiny particle. And eventually we were able to do that. But it wasn't until 2017 that this thing called scanning tunneling microscope was developed. And it was in 2017, guys, that's only a couple years, 2-3 years ago, in 2017, that we were able to see and actually look at atoms. We could see a single atom. It was a nitrogen atom. And it was really miraculous, especially for scientists, which you might imagine. So 2,000 or so years later, after we had all of this interest in breaking things up into their smallest parts, what do you get? More than 2,000 years later, what do we find out? We're able to answer the simple question, do atoms actually exist? Answer? Yes, they do. In the next video, it'll be a lot shorter, but I want you guys to watch the video. And I'm going to talk to you, and I have up here on the whiteboard a picture or a model of an atom. Now, of course, we're not going to see a picture of an atom, but we're going to show you a model of an atom. And the reason we use the model of the atom is because it simplifies the atom and its parts. And I want you to memorize certain things about the parts of an atom, and it isn't a whole lot. Do your best on it, though, because it will be on the quiz as well. And it makes you a better conversationalist when someone talks to you later about atoms, right? At least you'll be able to say what the basic parts of the atom are. So be sure and watch that video. And thank you so much for your time. As John Dalton, who was from England, by the way, would say, I really appreciate that you've spent this time with me. Goodbye.